Our next speaker, Seth Thuraisingham, is the CEO of Consilium, who after 16 years in computer engineering, founded Consilium some 11 years ago. I always forget my clicker. Seth will speak on the 6 principles to successfully lead in AI. Seth, come on up.
Yeah, I'm talking about the 6 principles to successfully lead in AI. I put this together just on reflection of all the AI projects that we've been working on the past 6 years. I interviewed our AI engineers, reflected on a lot of the customer projects, and poured all over our lessons learned documentation. Came up with these 6 principles. So the first one, and they're not all technology based either. So the first one is know where to play. So as business leaders, when you're working at your strategy, so just normal business strategy is, you need to know what your playing field is and how you're going to win in that play. That's a whole bunch of strategic choices. And in AI strategy, it's the way we focus down on that at Consilium is we think about, all right, there's 2 areas that we can play in, and that's S-type innovations and P-type innovations. I'll take you through the definitions. Not invented by me, but we certainly subscribe to it. S-type innovations are sustaining innovations. That's doing what you already, put simply, doing what you already do, but doing it better with technology. Lowering your operating costs, or lifting up your revenue, increasing production, and lifting up your revenue through the technology as well. If you're a mining company, you just need to dig more stuff out of the ground and do that more efficiently and get more to the customer, right? So that's a sustaining type innovation. P-type innovations are product type innovations. And that's thinking about how am I going to change the way customers interact with my product? How do I generate new markets? What's my next product look like to capture a new market share? One's more riskier than the other, but we're not going to go into that. Number 2, so number 2, the other important thing is, just on number 1 actually, is there's 2 very different processes when defining where you play for AI strategy. And when we look at, once you make that choice of S-type and P-type, the sustaining type innovations is a very traditional process. We look at your business workflow, we break out all the decision points, and it's all the decision points that is where the opportunity for artificial intelligence are, right? In your P-type innovations, it's more about a design thinking process, making sure the customers in the room, making sure AI engineers in the room, and all the business stakeholders are to ideate and find what those next potential innovations are. Number 2, having an experimental mindset. If you want to successfully lead in AI, it's key to having an experimental mindset. In fact, I would say that the experimental mindset is the journey to successfully lead in AI. In terms of, I subscribe, we've talked about failure and things like that, and I do subscribe to fail fast, but that's just not good enough on its own. Fail fast and cheap is a little bit better, but you could always end up with a whole bunch of micro failures that end up into one big failure. Sometimes you do actually have to win. And with the experimental mindset, it's more about sometimes you learn and sometimes you win. And eventually you do need a big win, otherwise your business is going to fail. And every learning is pointing you in the direction to a win. So by experimenting early, you're going to uncover the biggest challenges when adopting a new AI technology. And sometimes they're not all technology. We know there's going to be data challenges there. Sometimes they're things like if you're creating a product that's going to be personalising the experience for a customer, well, the training data set is going to be a whole bunch of personal data, potentially. Now you're going to have to deal with a whole bunch of privacy issues and the Privacy Act. And if your product is exposed to the EU, then you've got the GDPR to deal with. So if you start experimenting early, you can unlock those challenges and deal with them up front. Number 3, so data keeps coming up. Be smarter with your data. What I'm going to do is just take you through a lens, through a case study of some of the sort of low-level issues that we've come across when, in terms of being smarter with your data. So in this case study where we worked with One Australia and we used artificial intelligence and high-resolution satellite imagery to scan all of Australia to find all the vineyards and vine rows, we started off, the beginning of that journey, started off having a data set that was provided by One Australia. It was a ground truth data set. And it was just in Western Australia first. So number one, to be smarter with your data, you need a good sample size. So we got a reasonable sample size. We trained our model with 80% of the data and tested on the remaining 20%. And what we found is that we're getting vineyards, we're getting good classifying vineyards, and we're also picking up olive groves and picking up orchards and things like that. And there was this imbalance of things that was there. So we need to start categorising olive groves and orchards so that we could subtract them out and we could better classify vineyards. So there's this class imbalance that we had to address. So we needed to get more labelled information of vineyards and of olive groves and orchards and stuff like that. So we update the model, then we fly over to Adelaide and we try it out again on the Adelaide Hills. And there's these wonderful things, wonderful vineyards that are untrellised. And they're bush vines, right? And, you know, as not being an expert in the field, I was aware of bush vines. And there's certain reasons why winemakers and growers actually do that. But it caused another issue with having a good model, right? So there was a lack of data diversity in that particular category. So there was, number one, you need a good sample size. Number two, you need to address class imbalance. And number three, you need data diversity. So now we zoom in, we create another model to detect canopy gap in the vine rows. So here our training data set was viticulturalists that are walking through the vineyards and they've got a GPS, and when there's a gap, they record the location and create this data set. And, you know, it takes a lot of time to generate a reasonable data set. So we take that data set back and we build this model and run it and getting some really poor results. Go back to the data set and say, and then what we realise is the collected data is visually when you inspect the satellite imagery is that there was misalignments of where those data points were recorded. So on one vine row there was a gap and the actual recording was on the vine row next, so there was like this GPS drift that was occurring. And some of the things that we could have done better in the collection process was, number one, maybe a more accurate GPS. Number two, stand close to where the gap is. Number three, perhaps wait a little bit longer when you're recording that information to ensure you get good GPS lock. But the point here, more besides those three details, is that you need good governance and processes to collect your data to ensure good quality data is there. And finally, to make your data smarter, is thinking about ensuring that your experts are in the room and they're part of the process, right? Yes, our AI engineers are extremely brilliant in some aspects, but involving the experts, you know, no one knows everything, and involving the experts in a particular field will always produce a better result. Number 4, just a quick one, machine learning isn't the answer to everything. There was a case where we had a customer who was collecting, they had a sensor in a remote location, they were collecting signal information, it wasn't audio, and the challenge was getting a lot of information through a low bandwidth network. What we actually found was separating, so yes, we tried machine learning first, and compression didn't seem to work that great. And separating the problem from the solution, what we found was MP3 provided the best result, well, the MP3 algorithm. Right, so there are many algorithms out there. Machine learning isn't always the answer, but it is the answer to a lot of things, obviously. But yeah, it's about separating that problem from the solution and looking beyond that. Number 5, so this is an interesting one that I've sort of been thinking about with the team, is that prioritise deployment before accuracy. And this is kind of like about pipe cleaning your business model. If you get some predictions working in your business, you might understand all the other benefits that you can get and with a journey to improve it over time. So in agile software, it's like working software as a primary measure of progress. I would actually kind of sort of, extend that into, let's get predictions in your business so you can actually see how they work. Now let's give an example here with another case study. We worked with a customer and they were concerned about encroachments on their assets. And one indicator of an encroachment was detecting whether there were excavators near their assets. So if we think about there's the technology of detection, etc., but let's think through the business model where we detect, we send that information to a remote operating centre, and an operator is making a decision about what to do. From the operator's perspective, what they don't want is false negatives, right? So we need to make sure that we at least are able to detect excavators. But they're less concerned about false positives. So maybe we accidentally detected a few buses and a tree or whatever. They can deal with that rapidly in the remote operating system. They're already looking at the screen anyway. And over time, we can improve those things. So it's thinking about this pipe cleaning your business process and starting that journey. Talk about the experimental mindset, that journey to success. Likewise, we did the same thing for encroachment in terms of understanding vegetation. We don't need perfect accuracy and resolution of height, but it was useful in terms of situational awareness, whether it was grass or whether it was a shrub or whether it was above 5 metres. So we had low resolution to be able to determine height, but it still provides situational awareness. And that's something, I reckon there's two kind of unexpected benefits that, or maybe they're not appreciated until they happen, is the real-time nature of the predictions that you're getting and the situational awareness that you gain, the increase in value the increase in value to the judgments that you're making in your decision. Number 6, it's always about the people. It really is always about the people. And I think we're talking about it in the panel earlier. Technology is here to improve the value of all of our lives. We operate as businesses to either improve the value, to do all of these things, improve the value to our customers, improve the value to the shareholders, improve the livelihoods of our team, right? It's always about the people in that aspect. But even when you're introducing AI, now to all the experienced managers in the room, this is not going to be anything surprising. Typical change management processes still apply, right? Involve all the stakeholders in the process and you'll get more buy-in to the outcome. Provide transparency to the process of how you're introducing that in the AI into your business and you get more buy-in to the outcome, right? You let your child pick the vegetables from the garden, they're more likely going to eat it at dinner. It's the same kind of concept. And it's a little bit more, and there's a little bit more of a nuance here, is there's already a lack of trust with the outputs that you get and outcomes that you get from AI. So if you do change management well, it's not going to solve the whole problem, but it's going to help. It's going to help probably a lot. Most of the component will actually be through the good change management process. So here's another example. So that's just on change management, but the other aspect too, that just something that I felt we've been observing is the types of expertise required to train your data set. So when we talk about the machine learning type problems that we were looking at 10 years ago of classifying a cat and a dog and things like that, you can actually get a 5-year-old, someone's a toddler, to do that job. Here in this example, where we worked with a minerals exploration company, where we created a prospectivity heat map. Now, it's not a treasure map, it's a little bit different to that. A prospectivity heat map is basically telling the explorers these areas are more prospective and you should target your drilling resources in those areas. But in order to do that, we use geophysics data and drill hole assay data, and the way we labelled that information or tagged that information is the expert had to come in and look at the geochemical properties of these drill core samples, right? So they're saying this is highly prospective, this is moderately prospective, has low prospectivity. So, and probably do it on a numeric scale as well. But the key thing here is these are experts doing that. We can't get the toddler to actually ground truth that information in that way. And the point I'm trying to make is you're kind of digitizing expert knowledge through the training data. And when you think about AI strategy and looking at the opportunities and ideating and all those sort of things, what are the opportunities where you can bring the experts into the business to help them and build prediction models that's only going to make their job better and achieve better outcomes. So people were involved in the design build phase. There's a spectrum from anyone to expert in how they can train the data and build a prediction model. In the operational phase, when you think about change management, the traditional approach is the prediction comes out, it's adding value to your decision, and the person is at the end of that. And another thing that we're starting to investigate and do some research with defence is thinking about human as a sensor. We have remarkable biological sensors, and why don't we use that as inputs into our prediction models to actually improve our prediction outcomes, right? So, I mean, example, it happens already. Like the Twitter feeds are actually essentially human sensors. It's sensing events, sensing things. It's unfortunately sensing people's emotions as well. But filtering those things out, humans are adding into the inputs of prediction. And even the simple example of how we talk with Siri to improve a prediction outcome, we elongate our vowels and adjust our input to get a better prediction outcome as well. So overall, I believe that in terms of that last 6 point, it's always been about the people. That's how we feel in our business. Technology is unlocking our core human traits of creativity and empathy, and that's something that's going to continue into the future. It's been wonderful presenting. Thank you very much.